Hi everybody, welcome back. So we're going to continue talking about this introduction to inverse trigonometric functions. We talked about the inverse sine function, the inverse cosine function. Now we're going to talk about the inverse tangent function. Okay, and the main difference here is we can't really use the unit circle to actually see the inverseness of things. So let me just remind you what the graph of the tangent looks like. So remember, we have two asymptotes. We had several vertical asymptotes, but we have one at minus pi over 2 and pi over 2, and then the curve looked like that. So this was the graph of the tangent function. Now, if we ignore everything else, this graph, it does satisfy the horizontal line test, so it is 1-to-1. It does have an inverse. And if you pick any number here, let's call it x, even though it's on the y-axis, okay, there will be a unique point on the graph where the y-coordinate is equal to the x, and then this, then it's going to correspond to a certain number here, okay, and we're going to call that number, the x-coordinate of this point, we'll call that the inverse tangent of x, okay. And notice that you can pick basically any point on the y-axis and do this, all right. So at any point, any point that is, any real number, okay, so take any real number on the y-axis, you can do this, and notice that your result will always be between negative pi over 2 and pi over 2. So with that in mind, we can define the inverse tangent as the unique angle or the unique number between negative pi over 2 and pi over 2, such that the tangent of theta is x. Okay. Once again, some long time ago, people also called this the arc tangent, or the arc whose tangent is x. And of course, the inverse tangent of x is not equal to 1 over the tangent of x, because we know that this is called the cotangent. Okay. So the thing to keep in mind is that when we say that y is equal to the inverse tangent of x, we mean this implies two things. The tangent of y is equal to x, and y is strictly in between negative pi over 2 and pi over 2. It can't be equal to pi over 2, right? Because the tangent is undefined at those points. Okay. All right, so for example, we know that because we know the tangent of 0 is 0, the inverse tangent of 0 is going to be 0. Because we know the tangent of pi over 4 is 1, we know the inverse tangent of 1 is pi over 4. If you recall, what angle has tangent equal to square root 3? Okay, I believe that is pi over 6. Okay, actually that's not, actually it should be pi over 3, right? Pi over 3, I think, because we want the because we want this to be equal to square root 3 over 2 over 1/2, right? So we want this to be the sine. This is the sine of pi over 3, right? And cosine of pi over 3. Okay, so that's so the so that's this is correct. So the inverse tangent of root 3 is pi over 3, because you can see that this actually simplifies to square root 3. And then similarly, this is going to be pi over 6, the inverse tangent of that. The inverse tangent of negative 1, okay, well, we know that we could say 3 pi over 4, that has tangent. We know that the tangent of 3 pi over 4 is equal to negative 1, but we don't, that is not, 3 pi over 4 is not in this range, right? So we add pi to it, and, so we get the tangent of negative pi over 4. Or I should say, in this case, we subtracted pi from it to get a number in this range. So the answer is negative pi over 4. Okay. And you can check that the inverse tangent of negative square root 3 is going to be negative pi over 3. And for other values, you can use your calculator. But as long as you're in radian modes, that's great. So you just get the inverse tangent of 4.56. In this case, we get 1.355. We can round to 3 decimal places, right? So. All right, and as a property of this, the tangent of the angle whose tangent is x, of course, is going to be x, and the inverse tangent of the tangent of x is equal to x. And the nice thing about this is, you don't need to know what the value of the inverse tangent of x is, right? And the inverse tangent, if x, as long as x is in this range, it is the inverse tangent of the tangent of x. Okay, so we can see that the tangent of the inverse tangent of 1776 will just be 1776. The inverse tangent of 5 pi over 6. Okay, well, 5 pi over 6 is not in this range, right? 5 pi over 6, so let's subtract, we want to subtract pi from this. So this would be 5 pi over 6, and we're subtracting a multiple of pi because pi is the period of the tangent. So this is negative pi over 6, right? So this should be negative pi over 6. Okay. The inverse tangent of the tangent of negative pi over 8. Negative pi over 8 is in this range, right? So this will be negative pi over 8. And 8 pi over 3, that's not in this range. We can say 8 pi over 3 minus 2 pi. Well, actually, if we subtract 2 pi, that still won't be enough. So let's subtract 3 pi, and that will be negative pi over 3. Okay, because this is 8 pi over 3 minus 9 pi over 3 is negative pi over 3. So this is going to be negative pi over 3. So the important thing is you want to make sure that this number, whatever the inverse tangent of anything, is in this desired range. Okay. Next, lastly, I want to do a little bit of algebra here, where we solve for x, and a lot of times it's like just like if you remember last time in Math 128, if you could kind of solve for, if you were solving for x but you had a logarithmic equation, if you could say what the log is, if you said that the log of x is 2, you could go ahead and conclude that x is e squared. Okay, that's kind of what we're doing here. We can, if we can isolate the inverse cosine of something, then, or the inverse sine of something, or inverse tangent equals some number, then we're one step closer. So in this example, if we have 3 times the inverse sine of x, what can we do to isolate this inverse sine? We can just divide both sides by 3, and we'll get the inverse sine of x is equal to pi over 3. Okay. All right, well, what does that mean? That means that, in particular, the sine of x is going to be the sine of pi over 3, because we can take the sine of both sides. Okay, and then, now, we can, we'll assume that x is, in fact, in the desired range. So x is going to be, this is just going to be x, and then the sine of pi over 3 is going to be square root 3 over 2. Okay, and that's exactly what we want. Okay. All right. Do a slightly more interesting example when we have the 2 times the inverse cosine of 4x. Let's first again, we'll keep, because 4 is inside here. We want to just leave that here. We want to get rid of this 2 first. So let's divide both sides by 2, and then that will give us inverse cosine of 4x equals pi over 6. Okay. All right, now what does that tell us? Well, we can take, now let's take the cosine of both sides. Okay. And so this will give us 4x, and this will be the cosine of pi over 6. That's a cosine of 30 degrees. That's, well, it's again square root 3 over 2 in this case. And then we can divide both sides by 4 or multiply by 1/4. Same thing, and we'll get x is going to be square root 3 divided by 8. Okay. All right, so there's no one size that fits all, but this is, hopefully you can see this is the basic strategy. You know, you do a little bit of algebra, then apply your trigonometry, and then do a little algebra at the end. Okay, to solve for x, to isolate the x. Okay. Lastly, we haven't done a whole lot. We talked about inverses of functions. And we know how to find the inverse of sine x, cosine x, inverse tangent of x, even though those are not. We know, we said that those weren't just those functions by themselves weren't invertible, but if you restricted them to a certain range, it would be invertible. Let's look at something else. Let's say we had a function like 3 times the sine of 4x. Okay, and let's say we're restricting this to a certain interval, and we're hoping that this makes sense. What we're looking for is we want to find a function that if we substitute in for this x and simplify everything, we'll get x. Okay, so if you recall the basic strategy, so given a function x, f of x, if you wanted to find f inverse of x, we write, first thing we do is we write x equals f of y. So whatever x is in here, we replace it with y, and then set this equal to x. And then 2 is you solve for y, and then whatever the solution is, whatever y is, that's equal to f inverse of x. Okay. Okay. That was the basic strategy, which we used in Math 128. So, and if you will allow me to pause the video for a moment. Okay, sorry about that. So let's say if we wanted to do this for a function like this. Well, here's our f of x. So we'll write x equals f of y, so that will be 3 times the sine of 4y. All right, and then we try to isolate the y. Well, one thing we can do first is get rid of this 3. So we can divide both sides by 3, and we'll get x divided by 3 equals the sine of 4y. All right. Now we can take the inverse sine of both sides, because that will cancel with this sign right here. So we'll take the inverse sine of x over 3 equals the inverse sine of the sine of 4y. Okay. Now this will be just before y, as long as y was in a certain range, and that's why we were guaranteed, for why we had to put this requirement over here. Okay. So if we believe that, then this is just going to be 4y, and this will be inverse sine of x over 3. Okay, and then we just divide by 4, and we'll get y is inverse sine of x over 3 divided by 4. Okay. And that expression is going to be our inverse of x, f inverse of x. So f inverse of x, we can bring this 4 up here as a 1/4. And this will be inverse sine of x over 3. Okay. And then you can just go ahead and check that if indeed you plug this into here, the first thing will happen is that the 4 and 1/4 will cancel, then the sine and the inverse sine will cancel, and then finally the 3 and the 1/3 will cancel. So that should work. Okay. So there's your inverse function here. Okay. All right. One more example. Here f of x is equal to the tangent of 3x plus 5. We don't have to worry too much about restricting things because the domain of the tangent is all real numbers. Okay, so we'll write x equals the tangent of 3y plus 5. Okay, now we just have this tangent of something that's just all by itself, so we'll apply the inverse tangent of x, or the inverse tangent, to both sides. So the inverse tangent of x will be the inverse tangent of the tangent of 3y plus 5. Okay. And then we will have this and this will cancel, so we'll have the inverse tangent of x equals 3y plus 5. And now it's just basic algebra again. We first subtract 5 from both sides. And then divide by 3. Okay, so that will be y. And so f inverse of x will be 1/3 tangent, inverse tangent of x minus 5. All in parentheses here. Okay, and that is, so there's a little algebra here. Not so much trigonometry, right? Okay, so you'll see a couple problems like this on your homework, on your quiz. So a lot to digest here in this section. Go ahead, take the mini quiz, and start the homework. Get lots of practice, and see if you have questions. I'll see you next time.